So in this video, we're going to talk about the reduction of alcohols. Now, the two most important reagents you should familiarize yourself with is NaBH4, and this is called sodium borohydride, and then you have LiA, which is usually written as lithium aluminum hydride. And this is sodium borohydride. Now write this somewhere in your notes. Sodium borohydride is only strong enough, and it's a mild reducing agent. So it's only strong enough to reduce ketones and aldehydes. Lithium aluminum hydride on the other hand is very strong. So this reduces ketones, aldehydes, esters, and carboxylic acids. Right. And I like to think of lithium aluminum hydride as reducing everything. Right. So let's start with a couple problems and to kind of make us more understandable of the information here. So what if we were given this molecule here, right? And we react this molecule under lithium borohydride conditions in the presence of H2O. What would happen? Well, we just said from base of our definition, these reduces ketones and aldehydes. Well, we see that we have two ketones here. So this would be the observed product we will get, right? Reduces ketones and aldehydes, right, to alcohols, right? So we're going to form alcohols, and these are the reduction of alcohols. So we're making alcohols in the process. So what if we were about to give them this molecule here? And we subject this under sodium borohydride conditions in the presence of water. What would happen? Well, again, we just said sodium borohydride is not strong enough to reduce esters and carboxylic acid. So what would be the product? Right? We would reduce this alcohol. We will reduce this ketone here because it is strong enough. But esters, interestingly enough, it will stay the same, and this will be the product you will get from this reaction. It's just literally just not strong enough to reduce that ester. Now, what if I were about to take this same molecule and react it under lithium aluminum hydride conditions with water? What would happen? Right? What would be the product? Well, again, this reduces everything, right? And this would be the product. Notice how we got a primary alcohol, two hydrogens. So write this somewhere in your notes. Lithium aluminum hydride, you get primary alcohols from esters and carboxylic acids. All right. Now let's go through the mechanism to see how we get the product to be what it is. So what if we take this molecule, right? What if we're about to take this molecule here and we react it with lithium aluminum hydride? Remember, this reduces everything, right? Now, here's how I want you to think of lithium aluminum hydride and sodium borohydride. Simple, think of them as some source of H minus, right? Just to simplify things a bit, they're just some sort of H minus. So in the first step of the mechanism, the negatively charged hydrogen comes in, attacks the carbon containing the ketone, and maybe I should kind of note why, right? This oxygen is very electronegative, so you could imagine this is carrying a partially negative charge, and then our carbon, since it's withdrawing those electrons away, it's just slightly positively charged. So it's slightly electrophilic. All right, I'm sorry for my sickness here. Right. So in the first step, it attacks the slightly electrophilic carbon, and so this bond has to kick off on the oxygen, and we get something to look like this. Got an oxygen with a negatively charged, with a negative charge. Now, the second step of the mechanism, the oxygen that's negatively charged comes in, forms back that bond, and breaks that bond between that carbon and the oxygen, right? And then we get something to look like this. Maybe I should. Now remember, there's one hydrogen here, because again, and this is coming from that attack. So I shouldn't have, but for educational purposes, I kind of explicitly show that hydrogen there, right? And so once this reaction occurs again, that oxygen negatively charged occurs, we get something to look like this, right? We get an aldehyde. All right, we're gonna get an aldehyde. You're gonna get an aldehyde, and this is an intermediate actually, right? So we get an aldehyde plus this oxygen that is negatively charged, all right? So these are the products we get right now. This doesn't stay in the reaction for too long. Turns out that this reaction will actually occur again. So in another step of the mechanism, another source of H minus comes in, tap the slightly electrophilic carbon, kicks off those bonds on the electron, and we get something to look like this. Oxygen negatively charged, we had our hydrogen, but we also added one more hydrogen, right? And then we have this oxygen that's negatively charged over here, right? Now in the last step of the mechanism, and this is why we add water, and water just acts as some sort of H plus, some sort of hydrogen carrier, right? So maybe can't really write over there. So we have these molecules here, and once you add water, these are just some sort of protons. So you can imagine this comes, kicks off these electrons on here, and the same thing happens for this alcohol, right? And so you get that oxygen that's negatively charged, and so you get an alcohol that's two hydrogen plus another alcohol that has two hydrogens. Now you could see that we got two primary alcohols, and this is the reason why I asked you to write that in your notes, right? So that would be a plausible mechanism for how lithium aluminum hydride kind of deals with things. Now, what if we were about to give you this kind of right? So what if we're about to give you this molecule here, right? And you expose it to sodium borohydride conditions in the presence of water, what would happen? Well, again, remember, sodium borohydride is not strong enough to reduce esters, so we get an alcohol. All right, we get an alcohol. Now, what if we were about to take the same molecule and react it with lithium aluminum hydride, right? In the first step, and then water in the second step. What would happen? Sorry for my sitness again. And maybe we should kind of go through the mechanism to see what would happen, right? So we have this molecule here, and maybe we should go through the mechanism to see what would happen. All right. So in the first step of the mechanism, some sort of H minus will come and attack the slightly electrophilic carbon of the ketone, and that bond will kick off on the oxygen's lone pair. So we get something to look like this. alcohol that's negatively charged, right? Or an OH that is an oxygen that's negatively charged. So that's the first step of the mechanism. On the second step of the mechanism, these lone pairs comes back, form that double bond, kicks off these lone pairs on the oxygen, so the ring opens, right? So we still have this. Right, and now kind of see the best way to kind of draw this stuff so it makes sense. We have this ketone there, but now we form a hydrogen, right? We have a hydrogen that is already there. Now the ring opens. We have this carbon-carbon double bond with this oxygen that's negatively charged. All right. So what will happen after this? Well, again, the second and the third step in the mechanism, another source of H minus comes in, attack the slightly electrophilic carbon, kicks off the bond on the oxygen, and we get something to look like this. All right, now we have two hydrogens as a result of that attack, and now we have an oxygen that's negatively charged. All right. And sorry guys, my ring kind of gets ugly and uglier as we go, but that's not the important part of this kind of thing here. All right. And now we have two oxygens that are negatively charged. Right. So in the last step of the mechanism, this is where we add water, and these just serve as some sort of proton source. And these just comes, take proton from that water molecule, kicks off those bonds on the oxygen, right? And the same thing will happen to this, right? Another water molecule in the reaction might come, take one of those hydrogen, kicks off on the oxygen, and you get your neutral product to be something of this nature. You get an alcohol there, you have a hydrogen here, you have an alcohol at the top, and another hydrogen here. So this would be the observed product. All right. Now notice from the ester, we got a primary alcohol, and so that statement that we kind of spoke about in the beginning of the video kind of holds true.